By the end of this chapter, you'll be able to add, remove, replace, and loop over items in a Python list, the operations you'll reach for in almost every program you write. Each one takes a single line. You create a list by placing comma-separated values inside square brackets and assigning it to a name like fruits. Here we define 3 strings and print them. Leave the brackets off, and you get a tuple instead of a list, the mistake that catches almost every beginner. Now let us look at how to extract individual items from our list using their position. We add square brackets after the list name and provide the index number. It is crucial to remember that Python uses zero-based indexing, meaning the first item is at index 0. A very common mistake is using index 1 to get the first item, which actually returns the second item. This code grabs the first fruit and prints it beautifully formatted. If this is useful, subscribe. The whole series builds on it. Sometimes you need the very last item in a list, but you do not know its exact length. Python provides a fantastic shortcut where you use a -1 index to grab that final element. Here we ask for the item at -1 and print it directly. A frequent error is trying to calculate the length manually and making an off-by-1 mistake. Negative indexing avoids this entirely and keeps your code clean. Lists are mutable, which means their elements can be changed after the list is created. To modify an element, specify the list name and the index of the item, then assign a new value. In this example, we replace the first item at index 0 with a different fruit. Beginners often mistakenly try to use a string replacement method, but direct assignment is correct. The printed list now clearly reflects our update. The easiest way to add new data to an existing list is by using the append method. Calling append places the new item at the very end of your collection. We take our list of fruits and append an orange to the back. A common mistake is writing fruits equals fruits.append. Append does 2 things. It adds the item to your list, and it returns none. So that line modifies the list, and then replaces your fruits reference with none. You lose access to the very list you just changed. This code safely modifies the list in place and prints it. You can add a new element at any position in your list by using the insert method. It requires 2 pieces of information, which are the chosen index and the value itself. Here we insert a mango at index 1, pushing the banana and everything else to the right. People often forget that insert shifts elements rather than replacing them, leading to unexpected list lengths. Our output demonstrates the newly expanded list perfectly. If you know the exact position of an item you want to remove, you can use the del statement. Note that it is spelled del, not delete. Python has no delete keyword. The del statement completely removes the item from the list and shifts the remaining items left. We provide the list name and index 0 to permanently erase the first fruit. Beginners sometimes write del with parentheses, as if it were a function, or go looking for a delete method that does not exist. The output shows our list is now 1 item shorter. Sometimes you want to remove an item from a list, but still work with its value. The pop method removes the last item by default and lets you assign it to a new variable. In our code, we pop the cherry off the end and store it in a variable for printing. A frequent mistake is forgetting that popping modifies the original list permanently. Our output shows the popped item ready for use. When you do not know the index of an item, but you know its exact value, use the remove method. We tell Python to search the list for the word banana and delete it immediately. It is important to know that this method only removes the first occurrence of the value it finds. A common error is assuming remove will delete all matching items, which leads to leftover duplicates. The printed result shows a list without the requested fruit. To work with a specific group of items in a list, create a slice by specifying start and stop indexes separated by a colon. We create a slice starting at index 0 and stopping at index 2 to grab 2 elements. A common mistake is thinking the slice includes the stop index, but Python stops right before it. This code extracts a new smaller list and prints it. Slices are incredibly useful for managing data. The most common task with a list is iterating through its elements using a for loop. We define a loop that pulls each item from our list and assigns it to a temporary variable. The indented print statement then outputs a greeting for every single item automatically. A massive mistake beginners make is forgetting the colon at the end of the for statement, triggering a syntax error. Notice how every fruit gets its own distinct printed line. Lists are fantastic for storing numbers and performing calculations on them inside a loop. Here we iterate over a list of 3 numbers and calculate the square of each by multiplying the number by itself. Beginners often make the mistake of failing to indent the code inside the loop correctly, which breaks the logic completely. We append each computed square to a brand new list and print the final result. This demonstrates the immense power of list iteration perfectly. That is lists, and you have already met the for loop along the way. Next chapter we go deeper into loops, loops that keep running until a condition changes, skipping items with continue, and how to avoid an accidental infinite loop. Subscribe to catch it.